Have you ever wondered what truly holds matter together? Why atoms behave the way they do? What makes up the core of everything you see, touch, or even think about? Well, it all begins with the tiniest of particles, the proton. In today's video, we'll uncover the mysteries of this fundamental building block, taking you on a journey through its origins, its role in the atomic structure, and why it's so crucial to understanding the world around us. Let's dive in. Our story begins in the early 1900s when scientists were beginning to peel back the layers of the atom. The atom, previously thought to be the smallest indivisible unit of matter, was far more complex than anyone imagined. In 1917, a British scientist named Ernest Rutherford made a groundbreaking discovery. While experimenting with alpha particles and gold foil, he revealed that atoms weren't just small, indivisible blobs. Instead, they had a dense, positively charged nucleus at the center, surrounded by a cloud of electrons. But what was this positive charge made of? Rutherford proposed the idea that this central positive charge came from a particle he would soon call the proton, but Rutherford didn't know yet exactly what this proton was, its mass, its structure, or how it interacted with other particles. The proton, though small, would go on to become one of the central players in the drama of atomic structure. But it wasn't until 1932, when James Chadwick discovered the neutron, that the final piece of the atomic puzzle came together. Now let's zoom in. What exactly is the proton? On the most basic level, it's a subatomic particle with a positive electric charge. But its story is much more intricate. Protons belong to a family of particles known as baryons, which are made up of three smaller particles called quarks. Specifically, protons are made up of two up quarks and one down quark, held together by the strong nuclear force. These quarks are bound together by particles known as gluons. Imagine them as the invisible glue, constantly holding the quarks in place, keeping the protons stable. The proton's positive charge comes from the interaction between these quarks. While the quarks themselves are electrically charged, up quarks are positive 2 by 3, and down quarks are negative 1 by 3. It's the combination of their charges that results in the proton's overall positive charge of 1. But the proton isn't just a particle hanging out in isolation. It plays a central role in the atomic structure, and its presence is what defines elements. The number of protons in an atom's nucleus determines its atomic number, and, by extension, which element it is. A hydrogen atom, for instance, has just one proton. A carbon atom, on the other hand, has 6. It's this number that gives each element its unique chemical properties. It's also the protons that determine how atoms interact with each other. Their positive charge attracts the negatively charged electrons, creating an electromagnetic balance that keeps the atom together. Even more fascinating, protons play a key role in the stability of the atomic nucleus. They attract neutrons and other protons, balancing the forces of repulsion between like charges with a strong nuclear force that holds the nucleus tightly together. Without protons, there would be no atoms, no matter, and no universe as we know it. While the proton is invisible to the naked eye, its influence is everywhere. It's in the air we breathe, the water we drink, the stars that light the night sky, and even the very thoughts we think. Every atom, every molecule, every piece of matter is a testament to the power and importance of this tiny particle. So the next time you look at something, remember, it's the proton silently performing its duties at the heart of the atom that makes it all possible. Thank you for joining me on this journey into the heart of the atom. If you found this video insightful, be sure to hit the like button, share it with someone curious about the universe, and subscribe for more deep dives into the wonders of science. Until next time, stay curious.